So in this specific video, which is number 3 of the 3, I would do a combination of word capacity and word length expansion. Now, the third type of expansion that we get is actually a combination of what we've done already now. So we can do a word length and a word capacity expansion. Now, if you've got a question like this, for instance, let's say I've got 4K by 8s, that's what I have, and I want to construct a single memory which is actually a 16K by 16. So as you can see, I go from 8 to 16, that is a word length expansion, and I go from a 4K to 16K, that's actually a word capacity expansion. So it's a combination of the two. Now, the steps to follow here is always begin with a word length expansion, and then you do the word capacity expansion. So in other words, the first thing you have to do is to construct or draw a 4K by 16. So we've got this 4K by 8, and I first do a word length expansion, which is from 4K to 16. Then you do the final step, which is a 16K by 16. Okay, so the question is use 4K by 8 RAM memories and construct a 16K by 16. So as I've said, the first step is a word length expansion. So we're going to use this 4K by 8, and we're going to make a 4K by 16. We're going to construct a 4K by 16. Now we've done the process already. We've said if it's a 4K, that means a 4K here is 2 to the power 12. So my address bus will go from A0 to A11. There it is, from A0 to A11. It's connected in parallel to both devices, because this is 8 out, that's 8 out. It will give me 16 in total. As you've seen, we've also connected the chip select lines together, and in this case I'm just connecting it to ground, meaning that these two will operate together. And I've also connected all the read lines together and all my write lines together. Reads together and write lines together, not the read and the write. But yes, okay, so I've got from D0 to D7 from this memory device, and this one from D8 to D15 on this memory device. So as I'm saying here, this combination is now a 4K by 16. And if you look at, I've got a 4K by 16. So this is a new type of memory now. And I need a 16K by 16. So basically, if I've got a 4K by 16, because this is what it is, I will need 4 of these to form a 16K by 16. And you'll see it in the next sketch that I'm going to make use of 4 of these combinations. But now in this next sketch, of course, I'm going to go from a 4K by 16 to a 16K by 16, which means there will be a decoder also involved. Okay, so now we're sitting with these 4K. We've said basically I've started by using 4K by 8, and in the previous slide I basically showed you how to go from 4K by 8 to 4K by 16. So what you see here, these blue blocks here are basically my 4K by 16. So I've got one there, another one there, another one there, and another one there. I've got 4 in total, which actually now will be able to form a 16K by 16. So I've already shown that the 4K, that's why it's for all 4K devices can only connect to from A0 to A11. But because we need a 16K, if I look at this, a 16K memory, there will be 14 lines going from A0 up to A13. And I've used from A0 to A11, so I'm sitting with 12 and 13. So I've got 2 extra lines. And like we've said previously, 2 extra lines will always go to the decoder. So A12 and A13 will go to the decoder. And again, these 2 lines will only select between, well, these 2 lines, 2 input lines, has got 4 output selections. Output is 0, so, well, the active line is 0. If this one is activated, it's going low, and the rest will be high, etc. So with this specific addresses, it will either select this 4K by 16, or if this is going low here, it will select this 4K by 16. If that one is going low, it will select that combination of 4K by 16, and if this one goes low, it will select that one on the right hand side. So just to show you just one or two examples, if my address is all zeros, all 0 from A0 to A11, but also 0 on 12 and 13, first of all, if it's 0 on 12 and 13, this output will be low here, the rest will be high, and this blue combination, this 4K by 16, will be selected. And if this is all zeros here, basically this lowest addressed in this 4K by 8 and this lowest addressed here in the 4K by 8 will be placed on D0 to D7 from this RAM, and that one, the data from this one, will be placed on this data bus, giving you 16 bits in total. But all zeros, it will only select that 8 bits and these 8 bits here. The rest will not be activated. And if I make everything ones, let's say all ones here, it will basically point to the highest address in each and every memory device. But if it's all ones, that's also a 1 on A12 and also a 1 on A13, which means this line here will be high, this one will be active, which is low, the rest will all be high, and it means that this last one on the right hand side, this 4K by 16, this blue group here, will be activated, and the highest address in this 4K by 8 RAM and the highest address memory in this 4K by 8 RAM will be selected and placed on this 8-bit bus and also this 8-bit bus. So at one specific moment, depending on your address, there will just be, it can either be the first or the second or the third or the fourth. Only one of them will be activated, and only the data sitting at that specific selected memory position will be placed on the data bus here and the data bus there. And eventually I will then sit with a 16K by 16 memory device, which was developed from a 4K by 8 devices originally, as it says here. Let's look at another example. In this case, we want to go from a 4K by 14 to an 8K by 28. As I've said, you will not really get a 14 output lines, but it's a theoretical exercise, so we can have one. So if you want to do this, the first thing you will do normally is just to sort of build a 4K by 28. Like I've said previously, you must just do a word length expansion. And if you look at what we see here, that's basically a 4K by 28, these two together. These are 14 lines connected to that RAM, and these are 14 lines connected to this specific RAM. So this device here all of a sudden becomes a 4K by 8. If it's a 4K, the address bus is from A0 to A11, it's 12 lines. There it is. All the read lines are connected together, all the write lines are connected together, and the chip selects here. These chip selects are connected together to form this 4K by 28. That's my first step, as I've explained previously. And now we need to go from a 4K by 28 to a 8K by 28. And this is why I will make use of two of these devices. So that's a 4K by 28 and another 4K by 28, which will eventually give you this 8K by 28. And as we know by now, an 8K is 2 to the power 13, whereas a 4K is 2 to the power 12. So I've got one extra line, and we know by now if I've got one extra line, which will be A12, because if it's 8K, it's A0 to A12, which is 13 lines. A12 is my selection, and basically what you see here, this is a 1 to 2, which is basically the same thing as what we've seen in a previous slide, a 1 to 2 decoder. But okay, again, if this line is 0, A12 is a 0, that output will go active low, while this one here is high. And if this line goes high, that will be a 1, which is deactivated, and that one will be a low, which is activated. So depending on your address here, or what you put on here, it's either these two, which is a 4K by 28 that works together, or it's this two that works together and produces also 28 bits simultaneously. As you can see, the chip select of the right hand side twos are connected together, and the chip selects here are also connected together. So any address, again, if I put all zeros from A0 to A11 and also a 0 here, it will select the lowest address inside this memory and also the lowest address inside this memory, which is 14 bits and 14 bits. If it's a 0 here, that will be a 0. So it means these two RAM devices will be active, and this 14 bits from this lowest address will be placed on that data bus, and the same story, the lowest address of this memory will be placed on that data bus, and I've got 28 bits going out. And if I apply all ones, it means in all four, basically I'm referring to the highest address location if all are ones. But because it's a 1 on A12, it means that one will be active low, which means the data from the two right hand side RAM devices, this one here, and the data from this one here will be placed on the data bus, and that will go out. So in other words, depending on which address I use, it will either come from these two devices or it will come from these two devices. But eventually I will have an 8K by 28 with this combination. This is then the final video of 3 videos, which is dealing with memory expansion. The first one was the word expansion of ROM and RAM. The second one was word capacity, and the third one, and this specific one I'm finishing at this stage, is the one that deals with the combination of both. Thank you.